Hello everyone. Today we are going to work with a hyperbola and we're going to try to come up with the equation of it based off of a description that we've been given. So in our description, the hyperbola has vertices 6, 2 and negative 10, 2. So my first thing would be to plot those. 6, 2 would be right about here. And negative 10, 2 is right about there. And then I need to find halfway between those 2 points to get the center. Their y-coordinate is 2 for both of them, so I would just subtract the x-coordinate 6 minus the other x-coordinate negative 10, which gives me 16, and then halfway across, so if I divide that in half, would be 8. So I've got to count 8 from either of the vertices. So maybe we'll go from negative 10 if I count 1, 2, 3, 4, 5, 6, 7, 8 units. That will take me to the center. We can get rid of this. So this is the center of the hyperbola, which ended up being at negative 2, 2. All right, so since the vertices are in the x direction, that means that in my equation, x is going to come first. And because of the center, which I just highlighted, of negative 2, 2, with the x, I will do x plus 2 squared, because you always do the opposite of the coordinate. So since the x-coordinate for the center was negative 2, I do plus 2 in the parentheses. And then this is going to be over a number. Let's leave that blank just for right now. Minus, and then I'm going to have y, and then it's going to be minus 2 squared. Now the y is a minus 2 right here because its coordinate for the center was positive 2. So again, you always do the opposite in the parentheses. And I'll leave that blank in the denominator, and then equals 1. Now the goal is to figure out what the denominators would be. So, erase a couple things here. In the x denominator, all we have to do is look one more time. The distance between the vertex to the center was 8. So in the denominator, I'm going to put 8 squared, which is 64. So that is the x radius. You can think of it that way also. And the x radius squared is 64. And that's what goes into the equation. Now the harder part to figure out is the y radius. Let's delete this here. The way you could figure out the y radius is from the slope of the asymptote that they gave you. The slope of the asymptote they said was 1/4. So what that means is from my center point, I would count up 1 over 4. 1, 2, 3, 4. That would take me to here. But I have to keep counting until I get in line with the vertex. This vertex over here. So I'd have to count up 1 again over another 4, which will actually take me right to it. 1, 1, 2, 3, 4. Now, this is going to be the corner of the box that you draw when you draw a hyperbola. So let me get rid of just a couple of these things. And then the box is going to go like this. It's going 2 above and 2 below the center. As I counted up 1 over 4, up 1 over 4 twice in a row. So I ended up being 2 above the center in this direction and in this direction below it. 2, 2. So this 2 that I'm talking about is the y radius. And I put that in the equation, but I do 2 squared. So I end up with a 4 right there. And that's actually the whole answer. But if I finish drawing this, we're going to make room right here for the asymptotes and the curves. So if I finish drawing it, it's going to have really shallow asymptotes coming like this through the center and through the edges of the box, and then coming from this way. And then since the vertices were on the side of the box, that's the direction that the curves are going to open in. So let's just make room right here. So the curves are going to go like this and hit at the vertex and keep going close to the asymptotes in both directions. And then here was the other vertex, and then the curves. The curve on this side does the same thing. So that's what the overall hyperbola looks like for this one. And get rid of those extra arrows. So the equation that they were looking for is this right here. One other thing that you could do, if counting the slope was a little bit tricky for you, is if you notice the bottom numbers, the 4 and 64, when you take the square root of those, which would be 2 and 8, that's the radius of the x and y direction. So for example, this 4 that's under the y, the square root of 4, which is 2, is the y radius. And if you do the same thing for this other number, the square root of 64, which is 8, is what we call the x radius. Now, one thing that is always true is the slope of the asymptotes will always be equal to the y radius over the x radius. So if counting it out on the graph was too tricky, you could set up a proportion. So in this problem, the slope of the asymptote was 1/4, so 1 over 4. And remember, the number we did not know was the y radius, so let's pretend like we still don't know that. So we'll say y over, but we did know that the x radius was 8. So then if I just cross multiply, it's a pretty simple proportion. 4y equals 8, so y equals 2. And by solving that proportion, you get the y radius. So that's the y radius. And then you would be able to plug it back into your problem right here. But when we plug it into the equation, we square it. So we take the 2 and we square it, and that's another reason why that number would be a 4. And that's pretty much it. I hope that helps.